Hello, welcome back. Welcome back. I'm John, an old YouTuber. I did say last time I was an old computer. I'm not an old computer, but an old YouTuber. But I start to collect them old computers. I actually got this today. This small Acer Aspire. But I did not know it was so super small. I don't know if I can put my camcorder there. That's this model, old Intel Core i3 4th generation. So I pay about $100 for that, including shipping package. And I don't know if it's work. It should work. And have Windows 10. And Wi-Fi, some antennas back there, should be Wi-Fi, but if it's working I don't know. This is an Intel Core i5 650, the first generation there. This model M5910, Intel Core i5 650. It should have Windows 10. I don't know if it have Wi-Fi or not. So, but I got my pension yesterday, Wednesday, and today's Thursday, 1st September, and I just pay my bills. Now it's 2:30. Yes, I just download more PDF. That's this Acer Aspire I like to read about. And have to read about Acer. So I just made a new small read list there. Acer Aspire, Acer Predator, that's a high-end gaming. That's business machines. Veriton should be business desktop. This is high-end gaming desktops. This is that's from home users, low-end gaming. So, but that's for later. We need to finish all this about the memory. So, but I like to actually just to read about this different kind of Acer Aspire models. But I can do this later. I start to get tired because I made a lot of Danish video. Now I have added here. So I like to read this very soon. But we need to finish all this PDF with memories. Got the Acer Inch, the Acer Aspire, the Acer Predator is high-end gaming. That's business machines. Yes, but let's continue this. We can maybe do it this 20 minutes. And I need to take my socks off because I've just brushed my teeth and got water on the floor. My socks is a little bit wet. So actually I have to put it here so they can dry a little bit. But I just brushed my teeth. I don't know how the water can get down on the floor. I don't know how they did that, but they did that. Or could be some water from my underwear and t-shirts. I did wash my underwear and t-shirt in my bathtub yesterday. Could be a little water from that. Yes, let's try read this. That's the 2nd generation DDR2 SDRAM.
DDR2 SDRAM. DDR2 SDRAM double data RAID 2 synchronous dynamic random access memory type of IAM Swissbit 2 GB PC 2-5300 U555.jpg. Front and back of a 2 GB PC 2-5300 DDR2 RAM module for desktops. DIMM. Developer Samsung. 1. JEDEC TIP Synchronous Dynamic Random Access Memory Generation 2 ND Generation Release Date 2003 Standards DDR2-400, PC2-3200, DDR2-533, PC2-4266, DDR2-667, PC2-5333, DDR2-800, PC2-6400, DDR2-1066, PC2-8500. Clock rate 100 266 ms. Cycle time 10 3.75 ns. Bus clock rate 200 533 ms. Transfer it 400 1066 mount/s. Double data rate 2 synchronous dynamic random access memory. DDR2 SDRAM is a double data rate DDR synchronous dynamic random access memory SDRAM interface. It superseded the original DDR SDRAM specification and was itself superseded by DDR3 SDRAM, launched in 2007. DDR2 DIMMs are neither forward compatible with DDR3 nor backward compatible with DDR. In addition to double pumping the data buses in DDR SDRAM, transferring data on the rising and falling edges of the bus clock signal, DDR2 allows higher bus speed and requires lower power by running the internal clock at half the speed of the data bus. The two factors combine to produce a total of 4 data transfers per internal clock cycle. Since the DDR2 internal clock runs at half the DDR external clock rate, DDR2 memory operating at the same external data bus clock rate as DDR results in DDR2 being able to provide the same bandwidth but with better latency. Alternatively, DDR2 memory operating at twice the external data bus clock rate as DDR may provide twice the bandwidth with the same latency. The best rated DDR2 memory modules are at least twice as fast as the best rated DRAM memory modules. The maximum capacity on commercially available DDR2 DIMMs is 8 GB, but chipset support and availability for those DIMMs is sparse and more common. 2 GB per DIMM are used. 2. Contents. History. Specification overview. Chips and modules. Backward compatibility. Relation to GDDR memory. See also. References. Further reading. External links. History. Voltage 1.8 predecessor DRAM successor DDR3 SDRAM. DDR2 SDRAM was first produced by Samsung in 2001. In 2003 the JEDEC Standards Organization presented Samsung with its Technical Recognition Award for the company's efforts in developing and standardizing DDR2.1. DDR2 was officially introduced in the second quarter of 2003 at 2 initial clock rates, 200 MHz, RIFTO as PC2-3200, and 266 MHz. PC2-4200. Both performed worse than the original DDR specification due to higher latency, which made total access times longer. However, the original DDR technology tops out at a clock rate around 200 MHz, 400 mount/s. Higher performance DDR chips exist, but JEDEC has stated that they will not be standardized. These chips are mostly standard DDR chips that have been tested and rated to be capable of operation at higher clock rates by the manufacturer. Such chips draw significantly more power than slower clocked chips, but usually offered little or no improvement in real-world performance. DDR2 started to become competitive against the older DDR standard by the end of 2004, as modules with lower latencies became available. 3. Specification. Overview. PC2-5300 DDR2 SO-DIMM, for notebooks. The key difference between DDR2 and DDR2 is the increase in prefetch length. In DDR2, the prefetch length was 2 bits for every bit in a word, whereas it is 4 bits in DDR2's DRAM. During an access, 4 bits were read or written total from a 4-bit deep prefetch queue. This queue received or transmitted its data over the data bus in 2 data bus clock cycles. Each clock cycle transferred 2 bits of data. Increasing the prefetch length allowed DDR2's DRAM to double the rate at which data could be transferred over the data bus without a corresponding doubling in the rate at which the DRAM array could be accessed. DDR2's DRAM was designed with such a scheme to avoid an excessive increase in power consumption. DDR2's bus frequency is boosted by electrical interface improvements, on-die termination, prefetch buffer sound off-chip drivers. However, latency is greatly increased as a trade-off. The DDR2 prefetch buffer is 4 bits deep, whereas it is 2 bits deep for DDR. While DDR's DRAM has typical read latencies of between 2 and 3 bus cycles, DDR2 may have read latencies between 3 and 9 cycles, although the typical range is between 4 and 6. Thus, DDR2 memory must be operated at twice the data rate to achieve the same latency. Another cost of the increased bandwidth is the requirement that the chips are packaged in a more expensive and difficult to assemble BGA package as compared to the sub-package of the previous memory generations such as DDR's DRAM and SDRAM. This packaging change was necessary to maintain signal integrity at higher bus speeds. Power savings are achieved primarily due to an improved manufacturing process through die shrinkage, resulting in a drop in operating voltage, 1.8 V compared to DDR's 2.5 V. The lower memory clock frequency may also enable power reductions in applications that do not require the highest available data rates. Comparison of memory modules for desktop PCs, DIMM. Comparison of memory modules for portable/mobile PCs, SO-DIMM, according to JEDEC. 4. The maximum recommended voltage is 1.9 volts and should be considered the absolute maximum when memory stability is an issue, such as in servers or other mission-critical devices. In addition, JEDEC states that memory modules must withstand up to 2.3 volts before incurring permanent damage, although they may not actually function correctly at that level. Chips and modules. For use in computers, DDR2's DRAM is supplied in DIMMs with 240 pins and a single locating notch. Laptop DDR2 SO-DIMM shave 200 pins and often come identified by an additional S in their designation. DIMMs are identified by their peak transfer capacity, often called bandwidth. Comparison of DDR2's DRAM standards. Name a kit bus dimming standard tip module clock rate, MHz, cycle time, NS, 5, clock rate, MHz, transferit, mount/s, bandwidth, MB/s, CLTR/CDTRP, 6, 7, CAS latency, NS, DDR2 400 BPC 2320010020040032003315 C44420 DDR2 533 BPC 2420 *1336526653342663-3-311.25 C44415 DDR2 2667 CPC 25300 *16633366753334441 D55515 DDR2 800 CPC 2640020005400800640044410 D55512.5 E66615 DDR2 1066 EPC 2 8500 asterisk 2683.755331066853336-6-611.25 F7-7-713.125. Relative speed comparison between similar modules PC5300, PC640055554466655544, PC23200 4-4-4% plus 33% plus 60% PC2-3203-3% equals plus 20% PC2-4000 204-4% equals plus 21% PC2-4003-3% 24% 9% PC2-5305-5% equals plus 21% PC2-5304-4% 19% 3% PC2-6406-6% equals plus 20% PC2-6405-5% 16% equals PC2-6404-4% 33% 20% PC2-8507-7% 12% plus 6% PC2-8506-6% 25% 9% Asterisk some manufacturers label their DDR2 modules as PC2-4300, PC2-5400 or PC2-8600 instead of respective names suggested by JEDEC. At least one manufacturer has reported this reflects successful testing at a higher than standard data rate, 8, whilst others simply round up for the name. Note. DDR2XXX denotes data transfer rate, and describes raw DDR chips, whereas PC2XXX denotes theoretical bandwidth, with the last two digits truncated, and is used to describe assembly DIMMs. Bandwidth is calculated by taking transfers per second and multiplying by 8. This is because DDR2 memory modules transfer data on a bus that is 64 data bits wide, and since a bit comprises 8 bits, this equates to 8 bytes of data per transfer. DDR2 PVSF server DIMMs notch positions compared. DDR2 PVSF server DIMMs notch positions compared. In addition to bandwidth and capacity variance, modules can 1. Optionally implement ECC, which is an extra data byte lane used for correcting minor errors and detecting major errors for better reliability. Modules with ECC are identified by an additional ECC in their designation. PC2-4200 ECC is a PC2-4200 module with ECC. An additional P can be added at the end of the designation. P standing for parity, X, PC2-5300P. To be registered, buffered, which improves signal integrity, and hence potentially clock rates and physical slot. Intel A register trademark symbol 6402 advanced memory buffer. Intel register trademark symbol 6402 advanced memory buffer capacity. By electrically buffering the signals at a cost of an extra clock of increased latency. Those modules are identified by an additional R in their designation, whereas non-registered, aka unbuffered, RAM may be identified by an additional U in the designation. PC2-4200R is a registered PC2-4200 module. PC2-4200 ECC is the same module but with additional ECC. 3. Be aware fully buffered modules, which are designated by F or FB, do not have the same notch position as other classes. Fully buffered modules cannot be used with motherboards that are made for registered modules, and different